Okay, now how do you find the gradient of the curve at a given point? Now this corresponds to your worksheet C. So we are going to have a look at the question number 1, which says find the gradient at the point with x coordinate 3 at each of the following curve. The x coordinate is the 3, which means that we can, if I want to find the y, I can find the y. If I put here 3 cubed 27, so y is 27. But it's not asking me to find the y, it's asking me to find the gradient. Now to find the gradient when x is 3, now gradient is dy over dx. So let's start doing that one. The gradient is dy over dx. So you're going to write down y equals x cubed. Now you need to differentiate. So you need to write down differentiate with respect to x. When you differentiate with respect to x, that's why it becomes a dy over dx, and that becomes a d over dx of x cubed. Now d over dx of x cubed, according to the rule, 3 comes out, reduce the power by 1. So that is a 3x squared. And this is a dy over dx. But the question is saying when x is 3. So I'm just going to write down here when x is 3. The notation we use is this. You write dy over dx, put the 2 lines in the front, that's the mod line, modulus line, and x equals 3. And then you put 3, that 3 is from here, and 3 square. So when you put that in calculator, you get answer as 27. And that's your answer. Let's say we want to find out again the gradient of this point of this equation at point when x is 3. Exactly same one. We differentiate with respect to x. And that will give you dy over dx equals d over dx of 4x minus x squared. Now that side remain as it is. You know the rule. When you do, make sure you do all the steps in your assignment. So that's a 4x minus d over dx of the x squared. So the 4 comes out, and that's a d over dx of the x. According to that one, the 2 comes out, reduce the power by 1. Now the next step, 4 is here, and this thing d over dx is just a 1. 4 times 1, that's a times, minus 2x to the power 1. We usually do not write this 1, so 2 minus 1 is 1. Now the question is find the value of the slope or the gradient when x is 3. So x was 3. Now I'm just going to put that one. Let's do one more step actually. Dy over dx equals 4 minus 2x. Yeah, so just simplify it a little bit more. Now I need to do when x is 3. When x is 3, what is the gradient? Dy over dx, x is 3, going to be 4 minus 2 times a 3. Now 4 minus 6 is minus 2. And that is your answer. Now what does this mean? Dy over dx when x equals 3. What does this actually gradient mean for this equation? Now if I got this equation, the gradient of -2 mean it's going to go down. The minus gradient mean it's coming that way. Positive gradient mean it's going up that way. Now what does actually mean? Let me just go and plot the curve. If I just go on the Desmos and I plot the curve. Now this is the curve of the equation y equals 4x minus x squared. So, and this is the point where x is 3. Now I want to see if the gradient is -2 or not, which means at that point, if I zoom it more, that point the equation, the gradient is, it is traveling, it's going down along the y-axis. The drop is 2 and the travel along x-axis is 1. So change of y is 2, -2, because it's coming down, and change of x is 1. So it's going 1 in this direction and 2 down. So you can actually see at that point it's going 2, if I can zoom more, much better, 2 down and 1 here. So that's what the gradient actually mean. Find the gradient of the curve at a given point. So I think I've done some parts, so I'm just going to go the other one. So let's have a look at the E and the D. So let's start with the D first. Y equals to x squared minus 2x minus 1. Okay. Now, and I want to find out, in the question it says like, okay, find this the gradient of each curve at the point 2, 3. So I need to find out at the point 2, 3. The point that's provided is 2, 3. I just need to focus on the 2. If you put this 2 in the in this equation, the value of the y, you will get automatically 3, because that's the point on the curve. Now let's have a look. Find the we need to differentiate it. So differentiate with respect to x. Just to save time, I'm gonna call that one as f dash x here, because we can. Okay. And here I'm gonna write d over dx of x squared minus a 2x minus 1. Now let's differentiate. On this side, I got d over dx of the x squared minus, up to you if you want to put the x squared outside or inside, d over dx of 2x minus 1. Now when you are at this stage, let's differentiate. 2 comes out, reduce the power by 1. 2x 2 minus 1. Here first you take this 2 out and then you differentiate this bit. I haven't finished differentiation, so that becomes a 2x1. Usually we do not write 1, so I'm just going to make it disappear in the next one. Minus 2 is here, which is that 2. Now minus 1 comes out. This minus 1 comes out. Reduce the power of x by another minus 1. So that original minus 1, another minus 1. So I got the 2x. Minus and minus becomes a plus. Plus 2 x to the power minus 2. This is your f dash x, or dy over dx. But the question was when x is 2 at that point. So I'm going to write down dy over dx when x is 2. So you put 2, bracket another 2, wherever there is x, plus a 2, bracket another 2. And when you put that in calculator, that will give you the 4 and that will give you 1/2. So the answer of that one is going to be 4.5. Yep. So that's dy over dx when x is 2. Yeah, if you can straight away put that in calculator to get an answer of 4.5. Okay, now let's see if we want to do this one. Y equals x squared plus 6x, x squared plus 6x plus 8. How are we going to do that one? And we want to find it at -3, -3, 1. -3, -1. We only look at the first part, -3. So let's find the gradient. Now to find the gradient, obviously we need to do a differentiation. So you're going to write down differentiate with respect to x. And here you got f dash of x equals d over dx of x squared plus 6x plus 8. Then you're going to do them separate. So d over dx of the x squared plus d over dx of the 6x plus a d over dx of the 8. Now when you do that one, 2 comes out, reduce the power of x by 1. That's it. Here 6 is here, and you do d over dx of the x. And you know differential of a constant is 0. So that becomes a 2x to the power 1 plus a 6. Differential of this thing is 1 plus 0. 0. Okay, let's write 0. Then that will become f dash x, which is the differential, will become a 2x plus a 6. And now I need to do is at that point when x is -3, so dy over dx when x is -3, you're going to put 2 times -3 plus 6, and that will be 2 times -3 is -6 plus 6 is 0. Now that's a 0. What does that mean? That means if that's 0, the gradient is 0, it might be the peak. If this is the curve, it will be this top point, the very top point. Let's check. This is the curve, x squared plus 6x plus 8. Now, because the turning point is 0, the turning point, the gradient is 0 at when x is 3. This is when x is 3. This is the point -3, 1. And you can see it is 0. So it's completely flat. It can be either that way, or it can be like, depends on what's the equation of the curve is. When the gradient is 0, it's the turning point. These points are known as turning point. And that point is also known as turning point. At every turning point, the gradient is 0. So any turning point, the gradient is actually 0. The reason the gradient are 0 is because if we talk about in terms of motion, it is not moving. It has stopped.